Okay, so we're going to begin lesson 1.2, sets of real numbers. The central question is, how can you describe the relationship between sets of real numbers? And so what we're going to do is we're going to take real numbers and we're going to put them in a set. And these sets could be two different sets, or one could be a subset of the other. So a subset is what you see down here. So we have animals is the large group. And then animals can divide into vertebrate and invertebrate, but they vertebrate here. So they can divide it into birds, mammals, reptiles, using birds, subset, and passer type of bird that perch. So passerine is a subset of bird. Bird is a subset of vertebrate. Vertebrates are subsets of animals. So that's how they subsets. Okay, so you have to know what real numbers are. Real numbers of rational numbers and the irrational numbers. And that's on the next page. Okay, so here's the set of real numbers. And you can see that they take that and they divide it into two sets, subsets. One is rational and one is irrational. So rational numbers is a subset of real numbers, and irrational numbers are a subset of real numbers. The rational numbers are further broken down into the subset of integers, then the subset of whole numbers. So the types of numbers that are whole numbers, we have 0, 1, 3. You see no negatives in here. Whole numbers are not negative. There's also the square root of 4. What is the square root of 4? That's right, the square root of 4 is actually 2. So this is really the number 2, not the square root of 4. You have to simplify this to see the real number they're talking about. So whole numbers are a subset of integers. So integers consist of all these numbers plus the negatives. So the number lines that you might have seen hanging on Mr. Remley's wall last year, the number line are all integers. It has 0 in the middle, then it has negatives on the left, positives on the right. Now, integers is a subset of rational numbers, and rational numbers are integers, whole numbers, plus the fractions, decimals, repeating fractions, repeating decimals, and negative fractions. Irrational numbers are square root of 17, the negative square root of 11, the square root of 2, and pi. What do these four numbers have in common? Think about pi. It's a decimal that never terminates, and it's non-repeating. So all these numbers don't terminate and they don't repeat. These are all decimals that do not terminate and do not repeat. Okay, so let's try the example. Example 1a, the square root of 5. So can you simplify the square root of 5 into a whole number like we did with the square root of 4? Nope. So it's going to be an irrational number and it's real. It's not easy for me to write on this irrational number and real. It's kind of tight. Let me try though. So it's going to be irrational. You get the idea. And it's going to be real. Okay, so this B is negative 17 and 84 hundredths. So it's terminating, it ends, it's a negative, and it's a decimal. So it's not a square root that never ends and never repeats, because this does terminate, so it's not irrational. But it's not whole either, because it's a decimal. It's not an integer either, because it's a decimal. So it has to be rational and real. So let's make this one rational, and it's also real. Now, all the numbers that we're dealing with are going to be real numbers. We're dealing with real numbers. And there is another set of numbers, and no, they're not called fake numbers. They're called imaginary numbers, and you'll see that when you get to the high school. So real numbers has a set opposite called imaginary numbers, but we'll deal with real numbers. So all of these, you can say all these are real numbers. Okay, so C. Now it's important that you simplify as much as you can. So the square root of 81 divided by 9. The square root of 81 equals 9. Just move your denominator over. Now 9 divided by 9 is 1. So you're really dealing with the number 1. And you can see where the number 1 is. So 1 is a whole number, an integer, a rational, and a real. So all of those have to be written in for this one. So let's see. We'll start the easy one first. It's going to be real. It's going to be rational. It's going to be an integer. And it's going to be whole. Okay. All right. That was long. Okay. So on this page, this is page number 16. I should have told you the other one was page 15. This is page 16. And try these two. Pause it, try these two, and come on back. You'll see the answers. Remember, if you get them wrong, okay, you make a mistake. You learn from your mistakes. Don't just look at the answers. Okay, so for the first one, this is going to be a mixed number. It's going to be rational and real. So it's not a whole number because it has a fraction. And it's not an integer because it has the fraction. So it's going to be rational and real. For number 2, the length of the side of a square that has an area of 10 square yards. So area equals 10. And the formula for area for a square is A equal x squared, because we use x because both sides are the same length. You multiply the sides together to get your area. Now we're going to go backwards. To undo squaring, we take the square root. Now the square root of x squared is simply x, and this is going to be a decimal that doesn't repeat and never ends. It doesn't terminate. So that's the length of one side. And that number is irrational and real. Okay, so what I want you to do here is to go to your book on page 18. You're going to refer back to page 15 that has the little table on it so you can see what type of numbers are rational, what type are irrational, what type are whole, and what type are integers. You can record your answers here, but I also want you to record them on the guided practice answer problems. You'll find that on Schoology under lessons 1.2, the same place you found this. Then submit that to me. Please don't forget to submit it because a lot of you are doing the work but not sending it over to me. Thanks a lot, guys. Bye-bye.